Allow me to introduce this gentleman. I have known him for 30 years. He's a good friend of mine, which means it hurts deeply to say all the nice things I'm about to say. But he has been lecturing and teaching in University of Amsterdam for 30 years now on machine learning and artificial intelligence. So he has seen this grow and boom and become the key topic after years of being in the wilderness preaching the Bible. 6 years ago, I asked him to join me to found a company called MLPrograms, which I'll give you one guess what that does. And we have had artificial intelligence models in production, making decisions on people's car insurance and pricing in the United Kingdom and beyond for 5 years now. So we've faced in the real world out there, not talking about it, but actually executing on it, artificial intelligence making decisions as to who gets insurance and who doesn't. So this has led to a number of discussions we've had surrounding ethics, bias, and questions that arise. And we thought that we would come today and talk about our experiences and maybe introduce some of those topics to you to make you think about how this shapes your future and how these models are making decisions for you. As a consequence, we will be talking about some difficult topics. So racism, sexism, all sorts of bias and ethical questions. Just as a heads up and a warning, we don't shy away from those topics because our machines make those decisions, and it's important that we think about how those ethical questions are answered. Is that fair enough to say?
Yeah, I think as I often say to my students who are a little bit timid to when these subjects are brought up, they're not nice subjects often: misogyny, racism, pedophilia, all kinds of things that we really would prefer not to talk about. But it's important when we work with machine learning models, with artificial intelligence systems, that we develop good feelers, good sensors for the kinds of things that can go wrong. And if we don't talk about the kinds of things that can go wrong, they will go wrong and we'll not notice them. So these are some of the things that we do need to talk about.
So we had a chat about the various topics we've talked about in the business before and beyond. But one of the key points we've always had is bias in our data. So when you start with biased data, you get biased AI. Do you want to talk a little about how you determine bias in data? What's your starting point when you get a big lump of data?
Our starting point when we get a big lump of data, as Tom so elegantly describes it, is trying to extract some meaning from this lump of data. Often we find that the people who are holding data, in other words, insurers, insurance brokers, or insurance companies, are not very careful with their data. In order to be able to deal with the data carefully, you need to maintain and curate your data carefully. And often we deal with insurance companies who have data for many years or even decades, and they've been doing their business fine without ever using the kinds of techniques that we use to extract meaning from the data. And it's only when we go to do that we discover that there are inconsistencies within the data, or indeed that there are biases of certain kinds that are inherent in the way that these insurance companies are doing business. When we do our initial exploratory data analysis on the data that they use, we find actually there's a lot of bias inherent in the way that they work. And that's before we even begin to work with AI models on the data.
I mean, one of the key points is if you're 20 or 18 to 25, your propensity to crash is about 1.5 to twice that of somebody who's been about 50. However, your pricing for your insurance can be up to 4 times as much. Now, that's a historic thing where the market has decided we will just price this higher than it needs to be. However, now our data has this in it. So when we train a model based on this, we are now systemically inserting that bias into all future decisions that are made. There's racism in our data. We can see it and we need to adjust for it. So there are areas in the UK which are predominantly black. They will be priced higher. We can see that happening. We see that it doesn't have a combined reason from car crash propensity. And if we build based on that, we will create a racist AI. So then we become systemic. Then it becomes something where all future decisions made by this AI will have that bias in it, and we will have cemented it into the decision-making process. So this happens in things like policing, where if a police force has been inherently biased in itself, and then they take that data and they learn from it, then we end up institutionalizing that bias into artificial intelligence.
There is this amplification of bias. Interestingly, in recent years, we've been seeing these large language models. I mean, who has not tried ChatGPT or Siri or Alexa or one of these, or Gemini or one of these tools? The initial versions of these models were trained on large bodies of data and exhibited some biases. So you can identify racist bias or misogyny or other kinds of biases within this data. People have used these products to generate new text. So there's a lot of AI-generated websites out there. There's a lot of news articles that are generated partially or wholly by AI. And now we're training new models on this. So the models are training from data that has been built by models. So any bias that's in there gets amplified over and over. There's an interesting and slightly amusing piece of research where somebody continued to train generating new text and continue to train models upon it. And the model ended up sounding like a typical Donald Trump speech by the end of the whole process. This is not something that we want to have. So within MLPrograms, we look carefully for two kinds of things that I'll tell you about at the moment. One is what we call proxies. So, for example, we do not want to predict based on the color of someone's skin whether they should have car insurance or what the price of their car insurance would be. But a question that I ask of people in Amsterdam, where I live, and you can map it onto whatever city of the world you live in, there are some areas where different neighborhoods have people of different skin, predominantly different skin colors. So if I use a postcode to determine whether someone's car insurance should be expensive or not, I'm taking with me the color of their skin. So it's important, we call this a proxy. So the notion of postcode will be a proxy for race. This is something that we want to filter out, and we have techniques in order to do that to ensure that we're not using proxies in this way. I had a second example. Escaped.
So there's a concept we should explain to you. That's not a joke, but it's called explainability. So models basically break into two groups. It's not A or B, but predominantly they break into explainable models. So that is a model where I can tell you why the model has decided to, on that particular case, to give that particular outcome. And then inexplainable models, whereby I can't really tell you why did the AI make that decision. So if you look at an explainable model and you say to me, why did the system not give me a car insurance? Or why did the system decide I don't get that medicine? Or why did the system decide that I don't have a high social score now? I can tell you in an explainable model, I can say, oh, well, it went left, and then it was blue or red, and it went to blue, and then it was male or female, and it went to male, etc. I can tell you all the decisions on the way down. But on a neural network or a large language model as well, which is a neural network, I can't tell you that. I can't work that backwards. I can tell you, look, this is what we trained on, this is how we trained, and this is the model, and here's all the weights and biases of it. But I can't tell you in this specific case really why it made that decision. So when we come to talking about things like how do you challenge a bias? So when you say, I think I've been racially profiled, I think I've been, I think there's misogyny here, or there's gender bias, or whatever it is. What are the challenges that we face with the likes of GDPR and others, etc.?
Yeah, here in the European Union, we have the strongest data protection, consumer protection law in the world when it comes to data privacy. And I think that's a good thing. I'm a real supporter of GDPR, but it gives me a lot of headaches in terms of compliance. When we started the company, I took a course to become a certified data protection officer because I thought I need to know a lot more about this, about how GDPR works and how we need to respect it. And we spend a lot of time on data governance. I spent a lot of my time on data governance, a lot more than I thought I would when we started the company. One of the precepts of GDPR is, as Tom says, explainability. If I use a model to make a prediction about you, then I need to be able to explain to you why the model made the prediction that it did. So if a customer of one of our clients says, why is my car insurance so high? We need to be able to provide an explanation. Now, I have a lot of experience explaining machine learning. I teach very intelligent students, many of them smarter than I am. And sometimes I look at them and think, you don't understand what I'm telling you. Now, GDPR obliges me to go and walk in the park here and sit on a bench beside a random person and explain to them how my model works. That's a very high bar. So we're trying to address this in different ways. One of the ways that we approached this was to say, and this is an innovation within our company, is to say, if we can take our results, which I can show you lots of graphs and lots of numbers until you glaze over, but we're looking at ways of converting that into natural language. In other words, to take all of the numbers and graphics that we have and automatically translate that into a short paragraph of text. And the short paragraph of text is something I could show to the person on the bench in the park, and it would hopefully be more understandable and certainly than the graphics that are interesting to those who are exponents of machine learning. Also, we notice that when we translate it into plain English, bias becomes more apparent. You can see right there it's saying it's because you live in this area, or it's because of some other reason that could be suspect in one way or another. So this is a product that we're developing and innovating within MLPrograms in order to address the explainability requirement.
And like, to give you an idea of the sorts of things that face AI developers and people who are putting these systems into production, you might say, how do you optimize for a particular outcome that we want to have? So we call this the alignment problem, and anyone who works in AI will probably be aware of the alignment problem. I tell the machine I want this particular outcome, this way of doing it, and then it goes and does crazy things to achieve that outcome. And you're like, no, stop, don't be doing that. I didn't mean that way. So a good example of this is in medicine, for example. You say, well, we want to optimize for the most years of quality life. So that's typically the alignment in medicine. You say, I want more people to live long years for longer, good years for longer. But for example, there's a drug which for skin cancer, which works twice as well in Caucasians as it does in Africans. This drug is quite expensive. If you allow AI to decide and distribute the drugs to optimize the drug distribution, it will go give all the drugs to the white people, because that's what we told it to do. We didn't mean to tell it to do that, but we said optimize for the most years. So it'll go, right, all this drugs, all to the white people, none to the black people. It still works with black people. It just doesn't work as well. Nobody intended this to be a racist AI, but it's clearly a racist AI. So the same things we have problems. In our case, one of the simplest things can be color of car. Well, color of car is proxy for gender, because very few men drive pink cars. Right? So if you have a pink car, the AI goes, that's a woman. Now, hands up, it actually doesn't matter. Gender no longer makes a difference for car crash propensity. It's almost non-existent. So anyone who tells you that women drive worse or better than men or vice versa, it's not true. But this is a sort of thing where the AI can pick up on and become biased as a consequence. I mean, I remember Mr. and Mrs. being a problem for us because
we had to take the titles out, and some of them were.
We had to take the titles out, but leave in a marker to say is married.
Is married or is not married. Something else we're looking at is recently a consumer protection organization in the United Kingdom thought to make some phone calls to ask for car insurance prices. And they gave their names as different fake names, and the conclusion that they came to was that if your name starts and ends with a vowel, then you're very likely to have higher car insurance. I realize I'm in Portugal where many names start and end with vowels, but there are other racial associations with names that start and end with vowels. They published this with the notion of what they call the ethnic penalty. They suggested that if you had a brown-coloured skin, that you would pay £150 approximately more for your car insurance. Now, we found that very interesting, so we investigated with one of our main products, which is called MLP Score. It's what's called a propensity to claim product. In other words, an insurer gives us all the information about a customer who wants car insurance, and we suggested them the likelihood of this person making a claim in the next 12 months. We looked at the ethnic penalty from that perspective and looked at people who lived in different regions and different neighborhoods. And we discovered that our product was clean in that regard. So there was no ethnic penalty associated with what we were doing. So we feel that going the extra mile there and trying to show that our products are clean, are free of bias as far as we can do so. We feel that we would like to go that extra mile in terms of being a fair company, a company that treats our customers fairly.
And I'm going to wrap up shortly, but one thing that I hear from a lot of AI developers is, oh, if you just use a non-biased data set, then you can train a non-biased AI, right? That's often repeated as a mantra. Let me give you an example of how that doesn't work. If you take a perfectly statistically sampled population of people, right? So everybody here, let's just say, and you say, okay, we want to recognize faces, so facial recognition software. And you train it on the faces, and you say, get better at recognizing a human face. Off the AI goes and it starts to train. In that population, there will be a small number of Asian women, okay? And maybe the AI says to itself, or it doesn't say anything, it's not aware, but it says, if I drop these Asian women and stop trying to recognize them at all, I get, and they're 1% of the population, I get 2% better at recognizing Caucasians. So now I'm better at recognizing faces, and that's what you asked me to do, right? So if I just dump this subgroup, I get better at recognizing the main population. I'm a better AI now. Yeah, no, you're a racist AI now, and it's misogynistic AI. Great. So we've managed to create a racist, misogynistic AI from a perfectly distributed sample set. So just as a final note on that, how do you tackle that? How can you possibly tackle if your data set is perfect?
If your data set is perfect.
Yeah,
look, I mean, we've been talking about bias without really saying what it is, and everyone is biased. We're all a product of our experiences, but some of these biases could be positive biases, but many of them are harmful biases. And if you look at the constitution of your country, or you look at the United Nations Declaration of Human Rights, one of the very first articles will probably say that all citizens should be treated equally. And it will be followed with a phrase that will say something like, irrespective of their sex, their gender, some countries say the religion they follow, their race, their sexual orientation. So these are particular groups, or particular protected groups in some sense, that are protected by our laws. What we can do is look at these groups. We often don't have information on whether someone belongs to the group or not, so we need to find ways to substitute for that. But we look to see if groups are being disadvantaged in some ways, and we can do that by segmenting our data and seeing how that works. That's without getting too technical.
And our time is up, so we're going to have to leave it there. I'd like to say thank you to Breanndán for traveling all the way from Amsterdam to be here.
Thank you very much.